Specialty polymer coatings. Innovation is our specialty. With a client base that spans the globe, SPC has established a reputation as the foremost innovator of anti-corrosion coating and lining technology. SPC is the expert manufacturer and distributor of 100% solids, no VOCs, polyurethane, epoxyurethane, and advanced Novolac epoxy coatings. Our progressive methods begin in the lab and continue in the field with customized coating and lining systems formulated for the pipeline, marine, and industrial industries. This certification training module will assist you in application of SPC's 100% solids brush grade product lines for the pipeline industry. Before working with SPC coatings, you'll need to ensure your safety with proper personal protective equipment and hygiene. Whether preparing the surface area, mixing product, or applying SPC coatings, long-sleeve protective clothing should be worn over regular clothing. Cotton or disposable coveralls are recommended. Be sure to cover all areas of arms, legs, and torso. You'll need chemical-resistant gloves with a long cuff that will overlap clothing. Tape all seams to prevent any seepage of coating between clothing and gloves. You must wear steel-toe work boots and an industry-approved hard hat. While preparing the surface area for application, sanding, filing, or grit blasting may be required. During this step, one must wear appropriate respiratory protection as well as a blasting hood, side shield safety glasses, goggles, or a face shield to protect against abrasives. While mixing products, applying coating on a preheated substrate, or coating within a confined space, a vapor respirator is required where vapor is encountered. In areas with adequate ventilation, such as outdoor mixing and application, the use of a vapor respirator is normally not required. In this situation, side shield safety glasses, goggles, or a face shield should be worn. When working with 100% solids coating, cleanliness is essential. Employees should wash their hands and face with soap and water prior to eating. Clothes should be changed and cleaned on a regular basis, daily if possible. If clothing is worn for more than one consecutive day, it should be thoroughly examined to ensure that no contamination is present. Clothing that has had non-activated coating exposure should be removed and replaced immediately. If any coating, whether activated or not, comes in contact with the skin, it should be removed immediately by washing with soap and water. A barrier cream may be used in conjunction with protective measures as an additional safeguard against skin contact. Throughout the process of mixing and coating, be sure to have an emergency eye wash in close proximity. Personal protective equipment and hygiene is essential to ensure a work-safe environment. Surface preparation. It's important to follow SPC surface preparation steps in order to ensure time efficiency and quality coating results. Before applying coating, you will need to prepare the surface area with the following surface preparation tools: a steel file to remove weld spatter, an abrasive blaster to clean the surface area, produce an anchor profile, and enhance surface adhesion, a digital hygrometer to measure ambient temperature, dew point temperature, and relative humidity, a TESTEX spring micrometer and replica tape to measure surface profile of the substrate, blasted steel or visual photo comparators to determine the accuracy of the steel blast, a probe thermometer to take surface temperature of the substrate. In some cases, a preheating unit, such as an induction coil or catalytic infrared heater, will be required. You may also need a portable pipeline cover. At times, a solvent may be used for removing pipe surface contaminants. Once you have your surface preparation kit assembled, and you have abided by SPC standards of personal protection equipment and hygiene, you're ready to begin surface preparation. Step 1. Assess environmental conditions. Your first step to a successful coating application is to assess the day's weather conditions. If the weather is moderate, preheating is normally not required. In periods of inclement weather, such as extreme cold, snow, or rain, a preheating system should be used to maintain optimal substrate temperatures during the pipeline coating process. During these conditions, a portable pipeline cover may also be required. Step 2. Plan ahead. After assessing the weather conditions, plan on preparing and coating a reasonable amount of pipe within the day's work period. Be sure to have adequate coating and supplies to accomplish the scope of work for the day. Step 3. Inspect pipe surface. Look for any rough welds, weld spatter, or any contaminants on the surface to be coated. If there are any contaminants such as paint or markings, a solvent wipe may be required. Step 4. Remove weld spatter. Removing weld spatter helps ensure coating integrity. All weld spatter must be removed from the surface utilizing a metal file. Ensure you remove only weld spatter. Do not degrade the pipe surface. Step 5. Check for rough welds. Prior to coating, the welding crew has the responsibility of grinding any rough welds to remove high asperity areas. If the applicator has concerns regarding a rough weld, it is advisable to contact your foreman to evaluate and have any issues rectified. Step 6. Abrasive blast surface. Abrasive blasting helps with coating adhesion on the substrate. Unless otherwise stated in SPC's product documentation, all surfaces to be coated shall be abrasive blasted to SSPC, SP10 near white, MACE 2, or SA 2.5 cleanliness standard. Abrasive blasting must be initiated a minimum of 50 millimeters, or 2 inches, onto the existing coating to ensure proper adhesion. All blasting onto existing coating must be directed from the coated surface to the adjacent substrate, rather than from the substrate to the coated surface. Abrasive blasting must be done to all areas to be coated: the weld bead, pits, and structural members. Step 7. Clean surface area. Use a brush or compressed air to ensure the surface profile is clean of all blasting material. Unless otherwise stated in SPC product documentation, all surfaces to be coated must be completely free of moisture, soil, dust, and grit at the time the coating is applied. Note that any surface that has been allowed to flash rust must be sweep blasted. Step 8. Preheat surface area. To assess whether or not preheating is required, use a probe thermometer and a digital hygrometer. The acceptable substrate temperature range for the application of most SPC products is 10 to 100 degrees Celsius or 50 to 212 degrees Fahrenheit. Preheating of the substrate is required if the surface to be coated is below 10 degrees Celsius, 50 degrees Fahrenheit. The substrate temperature must also be a minimum of 3 degrees Celsius, 5 degrees Fahrenheit, above the dew point temperature. Preheating can be accomplished using a tiger torch prior to blasting, or after blasting with an induction coil or catalytic infrared heater. Applications at ambient temperatures above 20 degrees Celsius, 68 degrees Fahrenheit, generally do not require preheating. Preheating can be used to reduce the coating cure time, thus making the operation more efficient. For example, SP2888RG will cure in approximately 30 minutes if the pipe temperature is 50 degrees Celsius or 122 degrees Fahrenheit. It will cure in less than 5 minutes at preheat temperatures between 70 and 95 degrees Celsius or 158 to 203 degrees Fahrenheit. Cure determination is based on a Shore D hardness of 85 at 25 degrees Celsius, 77 degrees Fahrenheit. The chart above is for reference only. Roller sleeve and brush usage will vary according to pipe temperature. High temperature preheats will increase roller and brush usage. Step 9. Test surface profile. The surface profile can be measured using a TESTEX spring micrometer and replica tape Pressofilm extra coarse. One must test to ensure the resulting surface profile, peak to valley, is a minimum of 62.5 microns, 2.5 mils, to a maximum of 125 microns, 5 mils. Following each step of SPC surface preparation guideline will ensure you can be confident that coating application will go smoothly and be of the highest industry standard. Mixing coating. Mixing is a critical part of the coating process. It is important to properly follow SPC's coating steps in order to ensure quality coating results. Mixing can be performed in an enclosed space or open air. During cold weather application, an enclosed heated area is advisable. SPC coatings consist of two components, base and hardener. Kit sizes range anywhere from a ½ liter to 2½ liters or ½ quart to 2½ quarts. Coating kits should be stored at 5 to 40 degrees Celsius, 41 to 104 degrees Fahrenheit. Product storage temperature must be confirmed by referring to SPC product documentation. Storing kits at the recommended temperature will maintain SPC's high level of quality control. Many projects will have more than one kit size stored on site. Therefore, it is essential to identify the appropriate kit size in relation to the pipe diameter. Coating kits are pre-measured for correct mix ratio. Measured by volume, there are 3 parts of base to every 1 part of hardener, unless otherwise stated in SPC product documentation. Never use the base component of one product with the hardener component of another product. Mixing tools. When mixing SPC's 100% solids base and hardener, the following equipment is required: a variable speed drill, an appropriate mixing impeller, a spatula or mixing stick, and a CSA NIOSH approved mask if working in a protective enclosure or confined space. Once you have your mixing equipment assembled and you have complied with SPC standards of personal protection equipment and hygiene, you're ready to begin mixing SPC coating. The first step of mixing coating is to identify the appropriate product components. For this example, a kit of SP2888RG has been chosen that when mixed will yield 1 catalyzed liter or 1 catalyzed quart of coating. The applicator has identified that the base container and the hardener container are both SP2888RG, and the base and hardener are of the same related kit size. The identification of batch numbers for quality control documentation, as well as the verification of manufacture or expiration dates, is essential. This will ensure the coating you are applying is current product. Step 2. Confirm pot life. The workable pot life after mixing is stated within the product data sheet of the coating being utilized. In general terms, the working pot life will be between 10 and 20 minutes at an ambient temperature of 25 degrees Celsius, 77 degrees Fahrenheit. Pot life will be extended at lower temperatures and shortened at higher temperatures. Step 3. Premix base component. Using a mixing stick, scrape the walls and bottom of the base container to loosen the base component. Pre-mixing the base component loosens it up and allows for easier mixing when the hardener component is introduced. Step 4. Premix hardener component. You can premix the hardener component by shaking the container thoroughly. You can also use a mixing stick to ensure that the hardener is well mixed. Step 5. Pour pre-measured hardener component into the pre-measured base component container. Utilize a mixing stick to ensure the entire hardener component is transferred to the base component. Step 6. Mix hardener and base. Place the container of base component between your steel-toed boots. Using an appropriate mixing impeller attached to a variable speed drill, begin mixing slowly. Mix coating at a slow speed to ensure no vortex is created. After the initial mix has been achieved, a mixing stick should be used to remove any unmixed coating from the sides of the base component container. Once the sides of the container have been cleared of unmixed material, continue mixing with the impeller. The best method to achieve a uniform mix is to place the mixing impeller on the bottom of the container and slowly move the impeller in a circular motion. Coating that is completely mixed will have no color streaks or unmixed material on the walls of the container. Depending on the temperature of the kit, generally the coating will be thoroughly mixed after 1.5 to 2 minutes. If you're following SPC's mixing instructions precisely, you will ensure a uniform mix and quality coating results. Upon completion of the mixing process, mix a small amount of activated base component into the hardener container. This allows for safe disposal of any leftover hardener component. Application of 100% solids brush grade coatings. Once you have prepared the surface area, mixed your base and hardener components to the right consistency, and you have abided by SPC standards of personal protection equipment and hygiene, you are ready to apply SPC coating to the substrate. The following application tools are required: brushes, roller cages, short nap mohair roller 4mm or 1/8 inch pile, and a wet film thickness gauge to check film thickness during application. Approved application tools are available through SPC. Before applying coating to the intended surface area, refer to SPC Surface Preparation Checklist. Unless otherwise stated in SPC product documentation, ensure that the area is abrasive blasted to SSPC SP10 near white, MACE 2 or SA 2.5 cleanliness standard. That the surrounding area is clean. If it's windy and excessive dust, dirt, and debris are being blown around the area of the pipe to be coated, wet down the soil to ensure the coating will not be compromised. That the surface area is clean of soil, dust, and grit. That the surface area is completely dry. That the minimum surface profile is of 62.5 microns or 2.5 mils peak to valley. That the maximum surface profile is of 125 microns or 5 mils peak to valley, and that the temperature of the substrate must be at least 3 degrees Celsius, 5 degrees Fahrenheit above the dew point. Ambient application temperatures below 1 degree Celsius, 33 degrees Fahrenheit, must be watched carefully since ice crystals could be present in the surface profile, which could result in poor adhesion and reduced corrosion protection. Step 1. Pour mixture. To begin application, pour an appropriate amount of the coating kit onto the top of the pipe to enable the wetting out of the rollers. Step 2. Roll mixture. After applying a portion of the coating kit to the girth weld, the next step is to roll the mixture around the circumference of the pipe. First, wet out the roller. The coating should cover the entire surface of the roller, thus allowing it to spin with ease and apply coating efficiently. Roll mixture around the substrate, moving the coating downward a little bit at a time. It's best to maintain roller contact with the substrate until the coating that is being poured has been distributed evenly around the pipe. Never lift the roller from the bottom of the pipe. Always remove application tools from the top of the pipe. The kit is generally applied in multiple pours to achieve high builds of up to 1,778 microns, or 70 mils. Add appropriate amounts of coating to the top of the pipe and roll it down the pipe using the roller. Continue rolling the coating around the girth weld until it has been evenly distributed. A wet film thickness gauge can be used during the application process to ensure consistent coating thickness. Step 3. Brush mixture. After rolling the coating evenly around the pipe, use a wetted out brush to smooth the coating on the substrate. Use coating from the container and apply it to areas that require additional thickness. Be sure to feather the edges between the girth weld coating and the existing mainline coating. Step 4. Measure wet film thickness. Wet film thickness, WFT, is measured using a wet film gauge. The minimum WFT must be 508 microns, or 20 mils. The maximum WFT is up to 1,778 microns, 70 mils, without sagging. Be sure to check wet film thickness on several areas of the coated surface. If areas of the girth weld coating do not meet job specified thickness, use a brush to add more coating to thinly coated areas. Brush over all WFT testing areas to ensure coating integrity. Horizontal directional drilling and other special applications often require greater coating thickness. In these situations, please consult SPC. Step 5. The final step in the application is to belt or stripe the weld bead. Apply the balance of the kit to the weld bead. Brush around the weld bead to ensure adequate coating thickness to all high asperity areas. Total coating time varies depending on demands of the project, the pipe's surface temperature, and applicator efficiency. If any damage occurs to the freshly coated weld, additional product can be applied to the compromised area. All SPC 100% solids coating can be overcoated while the coating is still tacky. Be sure to follow all SPC guidelines when applying a top coat to a tacky undercoat. To prepare for later hardness testing, the applicator must place a 25mm or 1-inch daub of mixture at the top of the pipe. Please refer to the project specification for frequency. The test sample must be placed at the top of the pipe and at the outer edge of the newly applied coating. This will allow for a hardness test later without compromising the girth weld's coating integrity. Inspection. After the coating is cured to a dry, hard state, the girth weld coating is tested for hardness, thickness, and defects. Inspecting the coating quality requires the following tools: a Shore-D durometer hardness tester to measure coating hardness, a dry film thickness gauge to check coating thickness, a holiday detector to test for coating imperfections, and a felt pen to mark coating deficiencies. First, a Shore-D hardness tester confirms that the coating has cured to a dry, hard state. Insert the point of the Shore-D hardness tester into the testing sample. Press the hardness tester into the coating in one fluid motion to activate the measuring gauge. Once cured to a dry, hard state, the coating's dry film thickness, DFT, is measured using an electronic or magnetic dry film gauge. The minimum DFT must be 508 microns, or 20 mils. The maximum DFT is up to 1,778 microns, 70 mils. A successfully applied coating, when cured to a dry, hard state, will have a high gloss and be free from runs, drips, and sags. Occasionally, under challenging environmental conditions, testing may reveal imperfections within the coating. If coating deficiencies are discovered, use a felt pen to mark the coating for repair. Be sure to mark the area 25mm or 1 inch larger than the damaged area. Approved inspection tools are available through SPC. Proper inspection ensures pipeline coating integrity. Repair. If the coating does not meet SPC standards or the project's quality control criteria, a second coat of product must be applied to the defective area. To repair a compromised coating, you will require the following tool: 80 grit or coarser sandpaper, an abrasive blast unit, a heat gun for small areas, or an induction coil or catalytic infrared heater for large areas, a laser thermometer, an SPC epoxy coating kit, or an SPC epoxy cartridge and dispense gun with static mixer, a piece of cardboard, a stir stick, and a paintbrush. Approved repair tools are available through SPC. Repair. Step 1. Locate marked areas. The first step to repairing a compromised coating is to locate a marked area that was identified as deficient during the inspection process. Step 2. Abrade area. Once a compromised area has been located, the applicator must abrade the repair area using 80 grit or coarser sandpaper. The area must be abraded 25mm or 1 inch larger than the defective area. If the defective area is larger than 300mm square or 12 inches square, use an abrasive blaster. Step 3. Clean surface area. The area must be cleaned of all dust and contaminants. Use a paintbrush or dry compressed air to ensure the surface area is free of any material that might later compromise coating integrity. Step 4. Preheat repair area. In cold weather conditions, preheating a repair area may be required. Heating the repair area is achieved using indirect heating with a heat gun for small areas. For larger areas, use an induction coil or catalytic infrared heater. When preheating, do not burn the existing coating. Propane torches are not recommended. Use a temperature gauge to ensure the surface is at the appropriate temperature. Step 5. Apply coating to repair area. Coating application of the repair area can be done using an SPC epoxy coating kit or using an SPC cartridge system with a dispense gun. SPC epoxy coating kits are used when large areas or multiple sections need repair. The advantage of SPC cartridge systems is that the applicator can repair a single damaged area and then cap the cartridge for later use. When using cartridges, the applicator must apply the coating directly to the repair area using a dispensing gun with a static mixer attached. If not using a static mixer, squeeze out the required amount of coating from the cartridge onto a small piece of cardboard. Mix thoroughly using a stir stick. Then apply the coating to the repair area, ensuring complete coverage of the abraded area. Smooth out coating using a brush. When using an SPC epoxy coating kit, the method for coating application is the same. However, if there are multiple areas needing repair, the applicator must prepare all surface areas first. Once all areas have been prepared, mix up the SPC epoxy coating kit and apply the coating. Step 6. Post-heat repair area. In cold weather conditions, post-heating the repair area may be required. Post-heating is achieved using indirect heating with a heat gun for small areas. For larger areas, use an induction coil or catalytic infrared heater. When post-heating, do not burn the existing coating. Propane torches are not recommended. Use a temperature gauge to ensure the surface is at the appropriate temperature. Complying with every step of SPC's coating application guidelines will ensure a successful and efficient pipeline coating process. For more product information, contact SPC. Innovation is our specialty. If you have any questions or wish to be professionally certified, contact Specialty Polymer Coatings at spc-net.com.